Yes, so I see most of people, of course, stay in beginner or completely new to system dynamics. It's good to see that people are here to learn a little bit more about system dynamics and the system dynamics modeling process. We have an amazing instructor here today. It's one of the best in the field. And it's up to the challenge of teaching a lot of people today. We have 700 signups, so we're expecting a little bit around 300 maybe. We have around 170 right now. But yeah, I see a lot of beginners and completely new to SD, but I'm going to ask the advanced folks that we're going to have support break. Len is going to guide you then. But if you are advanced, we have some breakout rooms here. And by the time we get to this support break, if you can join one of these breakout rooms to help people who have some difficulties with their models, that will be amazing. Just repeating this, if you are advanced, when you get to this support break, if you can join one of our breakout rooms to give support for people, that will be very much appreciated. Just another question here, just to have an idea where are you guys from. We usually have a lot of people from different places. We usually cover a lot of time zones, and I really hope today is no different. So there's a new question for you on Poll Everywhere. I see the first answer here: Mexico, Nigeria, Dubai, Jakarta. I already see all the 5 continents here: London, Colombia. A lot of people from Mexico, Canada, London. You can put in the chat if you're not familiar with Poll Everywhere. But I'm really excited to have you all here. USA, of course, Beirut, Lebanon, India. Well, thank you so much for joining us today. It's really a pleasure to be here. Just remind to mute yourself if you're not speaking. Well, thank you so much for joining us. No more questions from my side. I'm just going to give you a very short presentation about the System Dynamics Society. It's taking a little bit long. So thank you so much for joining us. I'm Fernando Redifo. I'm the executive assistant for the society. And I'm here just to briefly introduce you to this webinar today and our instructor. So today you're here with the Introduction to System Dynamics Modeling. This webinar is sponsored by Powersim software, and that's why it's free. So I really hope by the end of this webinar, you learn a little bit more of system dynamics modeling, and you continue learning system dynamics in the future. And so really thank you, Powersim, for supporting us and giving this sponsorship to us. So we're able to open this space to teach more system dynamics. But also all the sponsors of the society. It's only through their help that we're continuing we're continuing to grow the system dynamics field. And if you'd like to sponsor the society, we can start a conversation at office@systemdynamics.org. And I'll be delighted to support if you want to sponsor the society. And if you're not familiar with the benefits of being a member of the System Dynamics Society, we have free access to all society seminar series, such as this one. You get a discount on our upcoming conference in Frankfurt in July next year. You get full access to the Society Scientific Journal, the System Dynamics Review. You get exclusive prices on our bookshop. And if you plan to learn more system dynamics, you get access to a pool of mentors and also discount on our partners' online courses. So if you're planning to join the society, we're about to open our 2022 membership period at the beginning of November. So you can wait until then, and then you have a full membership until the end of 2022. And just a reminder, if you don't know this course on system dynamics, and after this webinar, you get more interested in learning system dynamics, you can go to our online course catalog and find the System Dynamics Fundamentals course by WPI. And this is the first course of 3, and you can start after this webinar, and the other ones are coming up soon. And you can set the date for our conference in Frankfurt. We're going to meet live after 2 years. It's going to be from July 18 to 22 in next year. Small agenda for today. We have an introduction with Len, some model building, very exciting to do that on Studio. And we have a support break, as I told you. We have some breakout rooms. So if you have some doubts or you need some help to run your model, we're going to have some people helping out in the breakout rooms. And then we're going to close with a conclusion and discussion. That's all from my side. I'm really happy to introduce to Len Malczynski, and he's a professor at the University of New Mexico, sorry. And Len, that's all from my side. Thank you so much for joining us today. And here we go. We have 200 people, 215 people. Really excited to be here with you. Thank you so much.
Thanks, Fernando. Thanks to everyone at the Society office for making this happen. I remember in the past attending large meetings like this, and the first statement I want to make is, welcome friends and colleagues and soon to be friends and colleagues. As Fernando said, I'm Len Malczynski, University of New Mexico. I'm going to get started.
You can take over, Len. I'm sharing.
Yes, I've got it.
Good.
Can you see the screen now?
Yeah, we can see.
Okay. So I'm calling this session an exposure to system dynamics modeling. Let me just go forward here. Maybe. Now, there's my PowerPoint. This should be the first question you should ask yourselves. Will I learn the system dynamics method in this session? And here's my answer. No. It's truly impossible to learn something this powerful in a 2-hour session. Learning will require practicing. And of course, we're all different. We all learn differently. So my approach might not be appropriate for everyone. But the good news is there are many places to learn. You can go to the Society under the Learning tabs. For fun, last week, I typed into Google the phrase system dynamics, and I only received 424 million results. And I'll bet there are a lot of ways to learn system dynamics in those results. Okay, the other thing is I'll provide links to sites where you can learn, and once the video is ready to be posted, all the materials used today, the models, the spreadsheet, the PowerPoint, will all be sent to all of you. Okay. There's a spectrum of systems modeling uses, so to speak. There are uses that for a system are very routine, maybe balancing your checkbook or simple automated decisions on one hand. On the other hand, there are problems and systems that have a lot of human interaction. And we can't always solve those problems. Scroll forward. This is just another way to look at it, another rubric. Puzzles on the left and messes or wicked problems on the right. With puzzles, we use tools for routine decision-making, maybe some optimization, operations research like tools. But as we move to the right, we use tools for thinking. And this is my opinion of where system dynamics fits. From about this point all the way past the rightmost point. Incredibly powerful tool. Let's find out more about system dynamics. Okay, the beginning. A book titled Industrial Dynamics by J.W. Forrester, published in 1961. He presents a type of structure, and he indicated that models should have the following characteristics. Be able to describe any statement of cause and effect. Very important statement. He didn't say correlation, he said cause and effect. 2, be simple in mathematical nature. Well, what's simple for you might not be simple for me, so that's a relative statement. Next, use the nomenclature that's used in industrial, economic, and social settings. System dynamicists don't name variables X right? You'll see that in a few minutes. Next, it has to be extendable to large numbers of variables, thousands, without exceeding the practical limits of computers. If you recall, this was done in 1961. I'm pretty certain that the laptop I'm running today is more powerful than the computers Jay had available in 1961. Lastly, it has to handle continuous interactions. So in a sense, any artificial discontinuity that's introduced by what he called solution time intervals won't affect the results. We'll talk a little bit about that once we get the software open. And at the same time, it should be able to generate a discontinuity, a step function, an if-then statement, things of that sort. Let's go forward. How did he operationalize this method, this methodology? He envisioned an alternating structure of reservoirs. You could substitute the word bathtub right here. It's a structure of bathtubs that are interconnected by flows, or pipes might be a more appropriate word, okay? Metaphorically, people have sometimes called this bathtub dynamics. You won't hear that very often, but it's been used. So what kind of objects are in a system dynamics model? The stocks are the bathtubs themselves. Controlled flows in and out of the tubs are either automated or they're controlled by human decisions. Humans make decisions which control both the inflow and the outflow to those metaphoric bathtubs. And the interconnection between these objects are the pipes. And we'll see that on the screen. Feedback is very important in systems like this, and delay is very important in systems like this. And of course, our ability to handle feedback and model it, handle delays and model them. Go forward. So why would we ever want to build a simulation model in the first place? Something has happened. Change in the environment, in your business, your school, etc. And you want to do something about it. You want to understand you want to understand that problem better. You hopefully want to improve a system that doesn't seem to be working correctly. You'd like to improve the behaviors of the folks in that system. You might want to build a model to reduce complexity. All models are wrong. Some models are useful. You'd like to build a useful model. You'd like to avoid black box decision-making, and in that sense, make everything transparent. And system dynamics is great for that. Basically, you'd like to get qualified answers. When I use this word qualified, what I mean is people will be able to view, understand, and examine your model. That's the qualification level. Hopefully, you'll reduce the costs imposed by this challenge, and hopefully you'll save time. I've got a couple of links here. A great link of Introduction to System Dynamics from John Sturman at MIT, and then a little video on systems thinking. Don't worry about copying these down. You'll have all of these slides sometime tomorrow. I'm going to keep going. So here we are today, October 20th. What are we going to do today? You have a challenge. I took a quick look at the polling for your experience with system dynamics. I believe many of you have little or no conceptual knowledge of the method, of the system dynamics method. Most of you probably have little or no syntactic knowledge of Studio. When I use this fancy word syntactic, what I'm implying is you don't know which button to push. You don't know where to click your mouse to build a model. That's true of any software you might use. But hopefully, you're familiar with or are eager to learn about the problem domain. And today the domain I chose is the apartment building problem. So this is my mental model of what's going to happen. These ovals represent sort of capacity of Powersim Studio, which can do a lot of things in addition to the system dynamics method. Here's the system dynamics method embedded in that. And then you have this problem domain, which has a very, very fuzzy background because we're not always certain about everything in our problem. And here's our goal today: to move that problem domain onto the system dynamics method and Powersim Studio, acquire some knowledge of the method, system dynamics, learn some basic tool syntax that supports the method, that's Powersim Studio. And if there's time, I might show some what I call extra method syntax, something about this area out here. But I'm not trying to sell Powersim Studio. Okay, I was fortunate enough to get these slides from Dr. Nikki Zimmerman, who bravely did the first seminar in this series. She's at the University College in London, England. I made a couple of changes on the slides, but nevertheless, as we're preparing to do a simulation, what do? We typically have a problem definition, which in some sense is probably the hardest thing to do. While we're doing that, we're identifying the key variables. We're drawing behavior over time graphs, our dynamic hypotheses of how these key variables behave over time. And then we're getting to feedback diagrams where we're looking at how we believe these things are related causally, not correlation, but causal. Then, once we're done with that, which is typically done on paper, we go to building the model. The model is composed of what are called stock and flow diagrams. We identify the stocks and the flows in our previous step. We generate model equations for those stocks. That means integration. And for the flows, we identify the policies, again, either automated or humanly controlled. We simulate our model, get very frustrated, correct and simulate again and again and again until we're satisfied. And a side note here is there are about 25 tests that can be performed to look at the goodness of your ability to simulate the problem. And then finally, once we're satisfied, we can start doing analysis and implementing some of the policy alternatives. Okay, today, I plan to show Powersim Studio Express. Why Express? Because Express is completely free. I realize that some of you have downloaded Powersim Studio Demo, which has a 30-day lifespan, but it exposes you to all the power of Studio. Express does not, but Express has an indefinite license. So let's look at some of these points. The free edition gives you the ability to build models and run scenarios, to translate your models into multiple languages, to use what's called automatic unit control, which I will spend quite a bit of time on when we start building, to connect your model to spreadsheet data sets, both as incoming data and output from your model. It gives you access to a function library that's built in of more than 200 functions. And I believe today I will only show 2 of the 200. Okay, but because it's free, you can't get technical support for this product, for Express, nor can you get a service agreement for this version, Studio Express. But the good news is there's a Powersim Studio user group that's, I don't know, maybe its 18th year. It's absolutely free. We have a question and answer site. We have over 100 free models that you can download. And there are all kinds of tips and articles and things of that sort. You don't have to copy this down because I'm going to give you all these slides tomorrow. Okay, Express does have a few limitations. Here are the limitations. You can read them.
Len, just one
Yes.
question. They said the link seems to have a premium demo, not Express.
Yes, it's an error.
Okay.
So if you back up and go to the home of the Powersim Studio site and just navigate yourself to Express, I think there's a free downloads. I'm not sure. Maybe a couple of the Powersim people could put that link in the chat. Right, demo is got everything. Express has these limitations, but Express lasts, it's indefinitely renewable. But of these limitations, the only one I want to speak about is this first one. In my teaching, I find Express to be ideal. One, because it's free. Students always have a budget constraint. And two, the model can have a maximum of 50 variables. If you're an instructor, faculty member, this keeps students from going a little wild on model building. It's much easier to grade a model with 50 or fewer variables than, let's see, the biggest model I've worked on, about 3,600 variables, about 8 million pieces of data. So having 50 as a limit is great if you're an instructor. Go forward here. Okay, so we're going to build, at least in my opinion, a simple model using what's called an outside-in approach. This fellow over here has this puzzled look. Len, what are you talking about? Outside-in approach. So let me get rid of my pointer if I can, so that I can click on this link. Whoops. This is what I mean by an outside-in approach. The first thing we're going to do, right? We've done all the precursor steps. We've identified all the variables. I'm first going to add the constants that I found to my model. Why? First of all, it helps us to distinguish the exogenous from the endogenous. Basically a fancy way to say, what's the scope of this problem? What's outside the problem domain? What do I have no control over? Secondly, it indicates potential opportunities to grow the model scope. I've often said to students, take a look at every one of your constants. They might be representing a complete model, but you just don't have the time or the opportunity to discover the dynamics behind that constant. But because they're constants, you now know those are potential opportunities for growth. 3, again, it highlights the potential policy variables. And 4, it helps us to determine what units, what dimensionality will be required to make this work. And of course, we're all going to do this together. Secondly, I add my stocks. That allows what's called unit inheritance, so dynamic unit setting, and makes the model more transparent. We have a rule not to embed things in equations, therefore hiding them from our clients, our other team members. System dynamics modeling can be extremely transparent, and that's a good goal. Then I iterate through auxiliaries and rates to manage the model logic, to reinforce that unit inheritance, and finally, enforce the system dynamics methodology. you can use any of the system dynamics software that's available on the marketplace and build non-system dynamics models. It's not a problem. It's quite easy to do. But I think this seminar is a system dynamics seminar. So I'm going to ignore building things that are outside the methodology. Okay, so wait a minute. Oh, I went the wrong way. Sorry, got to click the button. Just a repeat. What could you identify from the text and a spreadsheet approach? So hopefully you've all downloaded that text about the apartment problem, which was 1962. I know it's hard to interact with how many people here, 247 of you, but you might want to go to the chat and say, did you identify any variables in that article that might help you with this problem? Anybody give me a name of something you'd like to keep track of in looking at this apartment building problem? Percentage of vacancies I see. Empty apartments, another good one. Vacancy, apartment numbers. Population, potential tenants, costs, stock of apartments, agencies involved, building rate, minimum rent, truly advertisement, occupancy, rent rates. Truly amazing that you got all those variables from that relatively short prose document. Okay, so what I'm going to do now is I'm going to close PowerPoint, and I'm going to open. And if you can see my screen, this is for all you people in the Netherlands, as a reminder. I'm going to open the Excel spreadsheet where I took the data from the textbook, Problems in Industrial Dynamics, and just type that data into a spreadsheet. Here are the columns that were in the spreadsheet on page 10. The book is out of print, so it's a little difficult to get a hold of, but I will be sending all of this to you tomorrow. Normal vacancies, actual vacancies. Those seem to relate to some of the variable names that you came up with. Apartments started, that means starting construction. Apartments completed, and actual apartments rented. Now, of course, this is Microsoft Excel. What we see here are the results of whatever is in that cell. I don't know how many of you have done this before, but I can click on formulas and show them. Right? Now I can see what's hiding behind those numbers. We're going to take a look at that a little bit later too. And this graph just shows what happens based on the data in the table. There are no dynamics. We don't know what the equations are at face value. Just wanted to show that. Okay. I'm going to go back to PowerPoint, maybe. Start it up again. Hold on, I'm managing a separate monitor. Okay, here we go. So, constants. This is what I identified by looking at the text, what I think were the constants. Normal vacancies, initial actual vacancies, a demand factor, which is embedded in the textbook and not in the article, initial apartments rented, timing, when does the step increase in apartments take place? Let's see if I can bring up Excel. I'm reading through the textbook and I say, gee, this is 2,000 apartments, 2,000. Where did that 2,200 come from? Right? Why 2,200? Why is it in year 3 that it's 2,200? I literally don't know. But that's why I picked this example, because we could go back to the textbook and see whether our model is appropriate or not. Okay, what stocks? Unfortunately, only one. Actual vacancies. And then the rates, apartments rented and apartments completed. And any auxiliaries that I need, apartments started. I did that for myself, apartments started, just so I could plot it and see what's going on. Okay, don't worry, don't try to copy all this. I'll repeat it on another screen while we're building the model. Okay. Oh, sorry, net apartments added also. So, wow, this is simple. Some of you advanced people are probably taking a nap, but some of you beginners might say, wow, this is simple. No worries, right? This is not the only approach to this apartment problem. There may be many other equally valid models, but today we're going to take a system dynamics approach. And ideally, you would have access to the stakeholders. Who's interested in this problem? Tenants, landlords, both? Government officials? Maybe. But I'm basing this on the textbook, and I see that in the chat, we're talking about trying to get a copy of that, something I'm actually working on. We can compare our approach and our results to what the textbook said was correct. And I'm following what we call best practices. There's a memo now that's celebrating, what year is this? 2021. It's more than 20 years old, called the System Dynamics Model Checklist. And then a little short paper that I wrote on best practices that's now celebrating its 10th year. Let's go back. Let's go forward. And now I've copied part of that screen in Excel, and I've duplicated those variables that I showed you. And let's see how good Excel is at doing dynamic modeling. Great. Excel had normal vacancies. We've identified normal vacancies. That's a good thing. Wait a minute, Excel didn't explicitly tell me what the initial actual vacancies were. It's implied because it happens to be the first number in the first year. So it's not transparent. The demand factor, nowhere is that transparent in the Excel model. It's actually embedded, I believe, in apartments started. Can't see it. Initial apartments rented, again, it's embedded and implied on line 3 of the Excel spreadsheet. The time of the step increase in apartment rental, again, implied. My brain has to figure out that 2,000 and 2,200 are different numbers. So there's no specific variable called the step increase in apartment rental. Sorry, the timing, which is what, in year 3? Where is the step increase? Again, that's implied, 2,200. And the completion delay, again, implied. How long does it take to complete the apartment building? Rebecca, you're asking me for the D memo. Let me.
No, we've got it, Len. I'm going to post it here. Monique and Tianco found it for us. So I'm posting it here for everyone. It's on the MIT site.
Okay, let's keep going. Did it identify the stocks? Yes, it did. Actual vacancies. Apartments rented? Yes, it did. Apartments completed? It did. And then apartments started, which is an auxiliary. It's neither a stock nor a flow, and no net apartments added. So this is our goal for today. If you can, you should be able to see this on the left. This is my interpretation of that problem built in Powersim Studio. You probably are going to ask me why different objects are named this way. That came from the best practices D memo, where constants are always in capital letters. Stocks have the first letter of every major word capitalized, and everything else is in lowercase. And our steps that we're going to take: add the constants with a name and a unit. Okay, there they are. Then we will add our stock, actual vacancies. Then we'll add a rate, apartments rented, the auxiliaries, another rate, apartments completed, another auxiliary, net apartments added. And I believe we're done. And now I'm going to go to Studio. Don't worry, I'll be able to show you all of this. I'm going to open Studio, maybe. Okay. I've got Studio open, and I'm going to take this model and interface and put it in what's called presentation mode. So I'm going to run Studio right now as if it were a PowerPoint demonstration. This is what the textbook shows. Some of you non-beginners who are still active in the chat, who can tell me what kind of variable this apartment starting decision is? Even though you've never used Dynamo, who can tell me? It's a flow. Oh, Corne answered. I would expect that. Esteban, Irwin, great. How about this rectangle here? Anybody? A stock. How about this rectangle down below? Average rent. Anybody? Auxiliary, correct. What I'm trying to convince you of is once you learn the system dynamics method, you can use just about any system dynamics piece of software. What you have to painfully struggle with, though, is the syntax. What object represents a stock? What object represents a rate? What object represents a flow? What object represents a constant? Go back to home. I just took the MS Excel thing, made a picture of the diagram and embedded it here. And don't forget, you will have this model tomorrow. Here's that MS Excel detail. I turned on equations, and I turned on the precedence dependence. And I'm joking here, but I'm sure everybody understands all this, right? It's very clear and transparent what's going on in these cells. No, of course not. Of course not. Spreadsheets have what we call failures. First of all, there's no way to separate inputs from outputs in Excel. Maybe you use colors. I don't know how you would do it, but you really don't know what the cell is used for. Is it a literal value that's typed in, like we saw on the sample spreadsheet, or is it a calculation? Well, in system dynamics, everything is transparent. If I use that, that's an input, that's a constant. If I use this, it's an auxiliary, I'm doing calculation. If I see this symbol, I know it's a flow rate or a calculation rate. The second thing, did anybody see any units in Excel? No, none, just numbers. Well, if you apply the system dynamics methodology in Studio, you have to use units. According to me, you can actually model without units, not recommended. So here, if I do an equation that says apartment capacity divided by average apartment life, Studio will solve that equation for me and give me the correct units. Finally, spreadsheets are two-dimensional. It is possible to combine several sheets and have a third dimension. Let's take a look at that. On the far left is a studio variable, initial apartments. And what I've done is put 2 dimensions in there, 5 different cities and 4 quadrants of the city, and put all my initial values in a simple array. When I need to use that variable in the calculation, all I have to do is reference the variable. I don't have to repeat any of this. I don't have to fool around with units. They're automatically inherited from this variable. And then I can do all kinds of things here to display. So let's go back. Let's go to home. Okay. Let's start building. I'm going to drop out of this model, and I'm going to bring up an empty model. Sorry, an empty copy of Studio. And I'm going to maybe set this, no, maybe to half screen. That's giving me some trouble. My mouse is misbehaving today. Let me get this over on one side. And on the other side, I'm going to go to the equations that we need. Here they are. Move this over. Hopefully it's still big enough to read, but not that big of an issue. Okay, I'm going to wait for a few minutes here. If you have downloaded Studio, everyone just please open Studio. Your screen might not look like mine, but that's okay. Just open Studio, close the welcome message if it's still open. If anybody's having difficulty, again, please type a message into the chat. There are folks here from Powersim and other advanced Powersim users who are also online. Okay, let's just assume that everyone's got it open. I'm going to go up here to File and say New. And up comes the new project wizard. Okay. Go to Next and ask me a question. What language, human spoken language, would I like to use for the variable names? And I realize there are people from all around the world here. You're welcome to use any language you'd like. You'll have to do some pretty rapid translating, but I'm going to stick with English. What file format would I like? I can go backwards in time and maintain compatibility with Studio 2005, which is now, what, 15 years old or so? I'm going to keep it at Studio 10 format. Hit Next. Time unit consistency, I'm enforcing that, which basically means I'm building a system dynamics model and I'm not using Studio just to be a calculator. Okay, go next. Is my simulation going to be calendar dependent or calendar independent? And here's an example. A calendar dependent model is typically based on data that you've collected that is time stamped. Data for, let's say, sales of laptops in the month of August 2021. Calendar independent is where you really don't care about that calendar date, but you do care to count months or years, regardless of when those months and years take place in the real world. You might run a simulation of 100 years and you don't care what the starting year is. That's calendar independent. Almost all the work I've done in my career has been calendar dependent. We'll go forward. What kind of calendar would I like to use? A bank calendar, 12 months of 30 days. Remember, all models are abstractions of reality. Is this good enough? 12 months of 30 days. Or a fiscal calendar, 4 quarters of 91 days each. Or finally, a true Gregorian calendar that would know that today, October 20th, 2021 is a Wednesday. Studio would know that if you pick Gregorian. I'm going to stick with.
Len, I'm sorry, I can't answer this question. Someone wants to know where you find this menu.
If you go to File and say New Project, right? Did that answer it?
Yes, thank you.
Let me just back up. I'll close it. So if you go to File at the top and just say New, it should default to this wizard. Go back through it. So next, I'm picking English as my language, Studio 10 as my format. I'm enforcing time unit consistency. I'm picking calendar dependent, and I'm going to stick with a bank calendar, but I want my time unit for my data to be year, because that was in the textbook problem. So only information they gave us was apartments per year, not per day, week, month, quarter. I'm skipping series resolution. That's for an advanced, much more advanced class. And then when would I like to start this running? Well, I'm going to start on 1/1/1962. And I apologize, those of you in Europe who put in dates differently. This is January 1, 1962. And I'm going to run it to January 1, 1982. 20 years. And my time step, which is a factor in model correctness, is going to be 0.5 years. All you have to do is type in 0.5, hit the tab key. It knows your model is based on years, so it assigns the year. Everybody, okay, let's see. Don't forget you'll have a recording of this, which you can speed up and slow down. Okay, so I'm completed. It gives me this review. Fine, I'm finished. Then it will bring up the project assistant, which I will close. But one thing my students tend to forget is there's this really nice help button. Don't forget help. You can click help and bring up this task assistant if you need it. I'm going to close it and start modeling. I would like, you can grab it. I would like to put on the first constant, apartment completion delay. It's in years and its value is 3 years. So now comes the syntax part. I'm sorry I can't make these icons bigger, but this little diamond shape is a constant. So I click on the screen and I'm going to type in capital letters because it's a constant. Apartment. I'm a really terrible typist. Completion delay. And then I'm going to do something that's maybe a bit magic. I'm going to say, put the equal sign and put a 3, 2 less than signs, YR for year, and 2 greater than signs. That's Studio's way of indicating. Now I can zoom this. That's Studio's way of indicating Let me redo the whole thing. Sorry. Because when I changed the screen, it accepted the variable. Do that one more time. Place it on the screen and start typing. Apartment, apartment completion, space delay, equals 3, 2 less than signs, YR. Before I hit enter, Studio is signaling me that there's something wrong. It's red, it's got a question mark, basically saying to me there's something wrong. Once I hit enter, it goes away. I now have a running model. What does this model do? Nothing. I'm going to extend my screen a little bit so I can grab a time graph, put that on there, put the model on there and run it. No errors, but of course, completely uninteresting, but no errors. Let's get the next constant. Timing of step increase in apartment rental. Everybody's going to grab a constant. Again, caps lock because it's a constant. Timing of step increase in apartment rental. That one's a little bit more complicated. It says that it's start time plus 3 years. I'm just going to hit enter. Studio's going to tell me I have an error. In fact, I'll try to run it. And Studio immediately gives me a message. Hey, wait a minute. There are undefined variables. You want to simulate anyway? Yes or no? No, I do not. I'm going to double click to get the definition of that variable, which is over here on the right. It's the start time. STARTTIME. That's an internal variable plus 3 years. Start time. Oh, I can make that bigger. So it's the start time, which is an internal built-in function, plus 3 years. So 3 years down the road is when I'm going to increase that apartment demand. It's, sorry. I did it and then canceled what I did. Got it. I still have a running model with no errors. Fantastic. Let's do the next one. What is that step increase in apartment rental? RNTAL. Some of you who have seen Dynamo know that in Dynamo, typically variable names were 4 to 6 characters. This is just the way I do it. I like to have transparency. I don't want this variable to be called STAR. I like to see the full thing. Therefore, it takes time to type it in. And I'm going to say that's equal to 200 apartment per year. Okay. I hit enter and I get a warning message that basically says, hey, this refers to a unit called apartment that doesn't exist. You want to create it? Sure, I do. I click yes, and up comes add unit wizard. What would I like to call it? Apartment. In plural, I want it to be called apartments. I go to my next screen. What kind of variable, sorry, what kind of unit is it? There are many choices: atomic, currency, derived, or custom. Well, I'm going to call it atomic. There's no standard international unit for apartment. And then I'll just hit finish and notice the error message went away. Okay. Do initial apartments rented next. And that one is again, oh, that's 2000. Oops, equals to 1, 2, 3 apartments per year. It likes that one. Initial actual vacancies. And what's that measured in? Apartments. That's equal to 1,000. All right, the demand factor, which was hidden from view in the Excel spreadsheet. And that one is 50% per year, 50% per year. Notice I haven't defined percent, but that's a built-in standard unit, so it accepted my definition. And then lastly, normal vacancies. A little bit of real estate here, normal. And that's equal to 1,000 apartments. Got it. No errors in this model. There are no red circles with yellow question marks, no warning signs, nothing. But this model is not very interesting because it's just a display of 7 constants, right? Make that a little bit smaller. Okay. What do we do next? If anybody remembers, we're going to do stocks, or what are called levels. Let's see, can I make this bigger? Should be able to. Okay, there's only one level. That's right here, actual vacancies. Okay, so what symbol represents stocks? It's right here, the rectangle. It's called the level in Studio. I click it once. I drop it on the screen. I'm going to call it now actual vacancies. And using the naming convention, the first letter of each major word is capitalized. I'm going to hit enter. Is there any variable called initial actual vacancies? No, here it is right here. So for transparency's sake, I'm going to get the link tool, which is this little arrow, click it, click on initial vacancies, click it into there. What's Studio doing now? Giving me a warning message saying, yes, I've connected it, but this stock is not making use of it yet. And oh, by the way, this stock is not defined at all. So I'll open this stock definition. And what I'm going to do is double click on actual vacancy, initial actual vacancies. What I'd like you to do though, is focus your eyes up here where it's got unit. Ready? Double click. It inherited the unit. I don't have to define it. It inherited it from the constant. The symbology changed. Studio uses dash lines for initializers. And now actual vacancies is there. Let's do this all together very slowly. Right click, put your cursor over initial vacancies and right click. That'll bring up a menu. And go to show auto report. Left click, and it'll show you how many apartments there are. The reason mine is showing none is I'm at the end of the run. I'm out in 1982. Let's go back to the start. And now it's showing me, make this a little wider, that my initial apartments is 1,000, which it inherited from this transparent external variable. Let's move that over. Okay. If you look to the right of your screen, you see I've highlighted two things in yellow. These are the flows that are going to be added to the model. You don't have to define these explicitly. Studio will do that for you. So because of that, I'm going to move to the next screen. Let's see, Hildy's got me an error on which one? Percent per year on the demand factor. Now I've got percent per year on apartments. Actual vacancies, initial. Well, if I'm going to have an error, let's just wait till, let's just wait till it comes up in the model. Okay, let's go to the next level. In PowerPoint, that is. All right, net apartments added. That's an auxiliary. I want to get to my rates, sorry. No, no rates. Apartments rented and apartments completed. What should I do? I need a rate called apartments completed, and I need a rate called apartments rented. So let's get a rate in there called apartments completed. Back to the screen, make it bigger. Move this out of the way. So I'm going to grab the rate tool, which is here. Click in the white space and then drag. And I'm going to call this apartments completed. Okay, it's giving me an error message. Why? Because I put no definition in there. What is the definition for apartments completed? From this diagram, I see it has to do with apartment completion delay, apartment started, and step increase in apartment rental. I haven't created everything yet. So what should I do? Keep modeling. I need to get those other variables into the model. The next one I'm going to add is apartments rented. And that is also a flow rate. I click inside of here, hold my cursor down, and drag, and call this APARTMENTS, rented. And it turns out that that variable is dependent on three constants. Step increase in apartment rental, when that occurs, and initial apartments rented. I'll slow down here in a second. Okay. So this rate is undefined. It depends on all three of these. So I'm going to double click on my link arrow and connect this to this, this to this, and this to this. And then click the pointer or hit escape. And now I've got to figure this out. What are the number of apartments rented? I'm going to double click here to open the definition. Well, first of all, I know it's based on initial apartments rented. The number of apartments rented, at the start of the simulation is equal to the initial apartments rented. But if you recall in Excel, it bumps up by, I think, 200 apartments. But when does that step increase take place? Right? Is it a plus step increase in apartment rental? Yes, that's true. But when does that step increase in apartment rental take place? So I'm going to use one of the built-in functions called step. So I'd like to step it up by 200. I'm hitting Control Enter here. And when do I want to do that? I put a comma. And I want to do it at the timing of that step increase, and then close the definition here. Let me make it a little bit smaller.
Please.
Everybody see that? Here, let me put in another line break. So it's initial apartments rented plus the word step, open the parentheses, choose that step increase from down below, comma, and then choose the timing. When does that step take place? And gee, I forgot. I'm going to double click here. And it tells me that takes place on 1/1/1965. If I click here, that step increases 200 apartments. If I double click here, it tells me the initial was 2,000 apartments. No error messages, automatically inherited the units, apartments per year, which is correct. All flow rates have to be per unit of time. Does the model run? Sure, it runs, but it's got errors. Let's make it smaller. Scroll way over here and grab a time graph. Put it on there. Drag vacancies onto it and run the model. Yes, I want to run it even though they're undefined. And oh my gosh, it goes to a negative 40,000 apartments rented over 20 years. Right, because I haven't done the apartments completed yet. Well, let's go back and do that. All right, apartments completed, if you look to the right, needs completion delay, step increase, and apartment started. Which one should I define first? I think I'm going to define an auxiliary now called apartment started. I click the circle, put that down here and call this apartment started. And that's got a connection from apartments rented. Just think about that. You're an apartment builder. Would you like to know, how do you make that decision of what to build? Move this down here, move this back up here. How do you make a decision of what to build and when? I need the demand factor. I'll just move it over and connect it. And I need normal vacancies. Okay, so that's the auxiliary apartment started. The definition is down here. Now I need to make this one bigger or smaller. Okay, now we can see it. So to define apartment started, I need how many apartments were rented plus a gap, right? Normal vacancies minus the actual vacancies. And then this secret hidden demand factor that we could not find in Excel. Let me open this up. Make this a little bit smaller. and say that it's apartments rented. So I just double click, make this bigger for you, plus, type a plus sign, parentheses, let me put in a new line with Control Enter, normal vacancies, probably came from some historical data set, minus the actual vacancies. Oh, I didn't bring in actual vacancies, did I? I'll just type it in. You have to use a tick because there's a space in the word, times that demand factor. And I've got it. I hit apply. Did not use the step increase. So what's wrong with this model version? Well, oh, I'm doing apartments started. It's giving me a warning sign because I didn't need this variable. And it's saying I'm missing something, which is actual vacancies. So I get my link, click it, drag it down. Okay, now it's happy. I'll scroll over to see the window. Graph it again. It still gives me the same error, negative, because I still haven't defined apartments completed. Let me take a little pause here. It's already after 10, right? When you build models, this is typically what happens. You leave things undefined because of the order at which you add variables to the model. Don't be worried about that. So let's see, what do I need to do next? Let's try to define apartments completed. It requires apartment completion delay. Apartment completion delay. It needs apartment started, which we just defined. It needs, oh, show the formula for apartment started, sorry. Let me get my Zoom going here. Whoops. Can you see it now? Apartments rented plus open parentheses, normal vacancies minus actual vacancies, close parentheses. And then that individual thing times the demand factor. So I've got a gap. What do I expect to be vacant? What's actually vacant? I've got that gap, and I multiply that times the demand factor. Okay, let's go back to defining completed. It's got apartments started. What else has it got? Step increase. And that's it. So what is apartments completed? Let's go back to PowerPoint and get that auxiliary apartments completed. Whoa, that is a mess, right? It's the delay in apartments started. I'm going to be lazy. Just grab the equation from PowerPoint and put it in here. And then you'll all be able to see it. The name of initial apartments rented. Did I not define that? Giving me another error message saying initial apartments rented is not there. Let me go back to my sheet model here. No, I don't need initial apartments rented. This is embarrassing. Well, there's an easy way to get out of it. I'll just open Studio. And go to the simple model. Again, you'll all have this tomorrow. And there it is. Apartments completed is equal to, now my mouse is misbehaving. Initial apartments rented. Where did we forget that? Oh, it's up there. Got it. Sorry about this. You forgot to put in the constant called initial apartments rent. Oh, there it is. It was hidden to me. Got it. Got it. Quite frankly, I don't know what is going on. But doesn't this happen in every demo? Expecting a close of parentheses. There we go. All right, let me make this bigger so that everybody can keep up with me. So it's called a delay pipeline, open paren, so delay PPL, open paren, apartment started, comma, and you should never type these. You should just click down here as you need them. Apartment completion delay, comma, and then the initial value, initial apartments rented, close parentheses. Yeah, Murphy's Law and demos, you're right. I really didn't need this variable. Got it. Oh my gosh, is the model running now? Let's take a look. And there it is. It's actually running. A model with 1, 2, 3, 4, 5, 6, 7, 8 constants, 1 auxiliary so far, 2 flows, and 1 stop. Okay. I haven't added the 2 other auxiliaries that I'd like to have just sort of just help me mentally know more about this problem. And they are net apartments added. So I'll get an auxiliary, net apartments added. That's in lowercase because it's an auxiliary. What's that equal to? Apartments completed minus apartments rented. Get the link, bring it over from apartments completed. Get the link again and bring it over from apartments completed. And I want it to be apartments completed. So I open this up, double click apartments completed, space minus apartments rented. It gives me an answer. That's it. The model's built and it's running. No error messages on the screen. I'm going to go back to the PowerPoint. No, sorry, back to my my demonstration in Studio, which is this one. Go back to presentation mode, which is that one. Gives me a little message. And there's that simple model. Again, we tried to build it. Don't panic if you haven't finished it. You'll have all this material tomorrow. All right, let's take a look at the model output though. I've got a copy of that model in this presentation. So, and I've added these buttons, interface buttons. I'm going to single step through it. I have to click how many times to get it to report. Does anybody know? Any of you experts out there? How many steps do I have to click to get the model to report for me a piece of data?
20 years?
2 years, right.
20?
No, just 2, because my DT, my time step for integration was a half a year. So I have to click 2 years to see the 2 times to see the result at the end of the year. That's the only reason. If I had made the DT 1/4 of a year, I'd have to click the step button 4 times in order to do that. Okay, so I'm just going to play it till the end. Right, this is the actual copy of the model we just built running in another copy of Studio. And you start to see some interesting things here. How did I get a half of an apartment? How did I get 22% or 78% or 31% of an apartment? What about this? Continuous versus discrete. If you're a beginner, if you're trying to convince people that they should be using system dynamics, John Sturman's got a great section in his text about why that's okay. Okay. A couple of reasons are that this continuous time flow is a good approximation for the real world. The errors it introduces are often small compared to our ability to measure things. And your choice of whether to make it a discrete step or a continuous step should depend on the purpose of the model. That's how we handle, that's the messaging we use with clients to handle continuous versus discrete. Go back home, output, and now comes the test. We'll reset the model. This is just a copy of the output from Excel. I'm going to single step. It's now drawing what Studio is simulating. When I finish, the lines will change shape. So the dashed lines are the Studio, and the solid lines are the Microsoft Excel implementation. You might notice here that this actual vacancies number of 1,000 is delayed a portion of a year. The increases here are delayed a portion of a year. How am I going to verify whether I did a good job or not? You might ask, are the patterns the same? Are the patterns the same? Well, yes, there's a decrease and an increase. I overshot their increase. Likewise here, there's an increase and a decrease on the red line, which is this red line, and then the gray line. That's probably introduced by the time step I took, half a year. Excel has no concept of time step. There's an assumption that each row in Excel is a new year. We did not do that. We are redoing our calculations every half year, right? So I'm going to jump out of this and let's play with that for just a few seconds. I'm going to go to simulation, go to my settings and make that a 1 year time step. Hit apply. Okay. And where's my comparison sheet? Here. Let's just run it again. No, didn't really help me any. Let's try that again. Let's go back to the model. Oh, sorry. Let's go to simulation. This is the material we entered during the wizard phase. And let's make it a quarter of a year. 0.25. Enter, enter. And let's go to the comparison again. Whoops. Where is it? Excel overlay. And let's run the model again. Really no difference. So what assumptions am I making? Well, I said that the delay was a pipeline delay, I believe. Right? A pipeline delay is similar to lining things up on your desk, and the one that's about to fall off the desk falls off first. The next thing about to fall off then falls off. So they're in order. So if I build 10 apartments in this year, that 10 number will proceed through time, and they will be the first apartments completed. There are many, many delay functions. The simplest delay function is simply the stock divided by a time unit. So taking this stock and dividing it by some period of time. That is the simplest way to do a delay. We don't have the time today to get into delays. Okay, so let me go back to presentation mode so we can wrap this up. And again, I'm sending you this model. We did the comparison. This is what the textbook suggested, quite a bit much more complex, right? Now we're talking about apartment dwellers. We're talking about families. We need to know about population increase. And we're not talking about whether they're rented or not. We could even talk about how many people are in each of those apartments. Do the apartments ever get knocked down? In our simple model, no, they don't. They live forever, right? So all of this can be added to the more simple model that we already built. Okay, so note there's a lot of differences in the tool syntax and the symbology, but with sufficient practice, the tool shouldn't matter. Okay. Oh, also somewhere out there on the internet is something that LaTanya Walker and I wrote on. If you have a Dynamo model, how can you easily convert it to Studio? Okay, back to home. I want to look at this one. So I started building one of those suggested solutions. We're not going to do that today. You can see this is much more complex. So I've got apartments in the planning stage, apartments on paper. Now I go through a delay process of building those apartments. Once I start building, they are called apartments in construction. Then there's a delay that gives me inhabitable apartments, right? Actual apartment capacity. And here I've got apartment wrecking rate. Now I haven't added the rental yet. I haven't added anything in the model about determining rent. Nothing is in this simple model on the occupancy mechanism, which means rented. None of that is there. But you can see here that the model is getting more and more complex. And what I did on some of these, I showed the auto report as a number. This one, I'm showing it as a graph. So let me run the model all the way out. And I think I can do this. Let's see if I can move it. And I put an image over that stock. That's actually an image of an apartment building somewhere. I think it might be New York City. But at any point in the model run, got to make it smaller again. At any point in the model run, I can see the value of any variable. If I go out 1, 2, 3, 4, I went out 2 years. You can see the graph drawing in the lower right, and you can watch whether these numbers change. Let me switch this back to a numeric auto report. I can't do that. I'm in presentation mode. And let's see if apartments under construction will change. Nope, it's pretty constant, 2,000 apartments. Why? I haven't rented any yet. Okay. Couple more slides and then I want to go to questions. So that was the suggested solution. If you're interested in this, what can you do? What should you do next? Next steps. Go to the Powersim Studio website. Or, oh, that's over here. There's a whole series of getting started videos. And click here. It's going to open. I did all of this within Studio. It's going to take me to the Studio website, right? And you'll be able to navigate through this and find those getting started videos. There's also, I don't know, 10 or so webinars. I'm opening another Powersim Studio website, which was recently redesigned. And you can find all of this information here by cruising around the website. Maybe going to this main menu. Gee, modeling tools, getting started is right here. Click on that. And you've got all these videos that you can watch. Typically, they also come with a simple model. Likewise for the webinars. Okay. Don't forget tutorials. I'm going to go out of presentation mode. I'll come back in a minute. Don't forget help. Even with Express, there's quite a large number of tutorials built in. Typically what they do is you open one, start the tutorial, and save the model. It'll load that model right here. Click to open the model. I don't want to do that because I've already got this one open. But don't forget the help. There's a tremendous amount of information there in the help. Go back to presentation mode. Go to next steps. You've also got the System Dynamics Society. If I click here, it'll open that in a browser. Go back to home. And then you have hundreds, if not thousands, of people who can help you. The Powersim site, you can go to our MindSci computing site. There are over 100 models there, including all the models from John Sterman's Business Dynamics that have been rebuilt using standard practices. You can go to the user group. As I mentioned earlier, there are about 100 models there. And then I highly recommend the Creative Learning Exchange, which is for younger students, elementary school and high school teachers. But there's adults can learn there too, the way I say it. I'm going to do this. I'm going to go out of this copy of Studio. I'm going to go back to PowerPoint. And put that back into presentation mode. And get out of this screen. Where do I want to be? There's the model we built. And a strange coincidence. The New York Times, NYT, sends me news every day. On October 15th, they send me news about an apartment model construction problem. Inflation is altering the apartment construction rate. We did not model inflation in our simple model. We have nothing about the economy that could be added. Here's a link to that article, but strangely enough, that is 21,500 odd days later, humankind is talking about the same problem, apartment buildings. A pure coincidence, right? It's the exact same problem. I guess nobody in the apartment industry is aware of system dynamics. Good application of system dynamics and model building help, right? There's that model again. All right, let me leave that up and open things for questions. And I can answer verbally or through the chat.
I can see there's a few questions in the chat, Len.
Okay. Could you compare, contrast stock flow agent-based? Very good question. Definitely, Jay, you should look up the article that John Sterman and I believe Hajir Ramandad wrote, comparing discrete event. I think discrete event, agent-based, and continuous. Basically, the hardest part of agent-based is defining the behaviors or figuring out what behaviors you'd like to embed. In the long run, if you have lots and lots of agents, you start to approach a system dynamics result. If we had a lot more time, I've got two models about immigration that are built, one in system dynamics and one in agent-based. And when you run them with lots of agents, the result is approximately the same. But truly get that article. It's Sterman and Ramandad, somebody out there I already have it. Let's see, I'm scrolling through. Why it's not possible to create a unit called product. Let me bring up Studio. I've got 3 or 4 versions of Studio open. I'm going to open up the Explorer pane and go to Global Units, right click and try to add a unit called product. And I say next. And it says to me, product is a reserved word. It cannot be used. All right. So I'll go to help, contents, move it up to the screen. I'm on index and I'm going to type the word product. And it's a function. That's why you can't use it. It's a function, right? Product is a function that returns the products of all the elements in the string. So X times Y times Z, etc. If you have an array, it'll multiply the first times the second, etc., etc. So you can't use the word generic word product. So I make a suggestion. How about the word item? There is no reserved word called item. You might use that. Okay. Let's see. For those who can speak Spanish, someone sharing. Watch this. I think it's this model. I think this is the model we built. I'm coming up here to the language button. No, that's not the right one. I've got the Spanish English version open somewhere on my computer. I don't see it though. Not that one. Not that one. Let me get it out of my folder. Hold on just a sec. Just a sec. I know I built one. Where is it? Here it is. I'm just going to close the assistant. Why won't it let me close it? It's still loading. Okay. Notice all the variable names are in Spanish. Hopefully you can see this. I can come up here and switch it to English. And now they're back in English. And there's no magic. You have to do the translation. And the only time I've ever done this was I built a model in Taiwan that was in Chinese and English. And I had my consultancy partners from Taiwan build the Chinese version because I don't speak Chinese. All right, let's see what else we've got in the chat. Agent-based pivot sum, right? Let's see. I want to model contract farming performance. Nature of contract. Okay, basically I think, is it IFAT? What you're talking about are variables that might be qualitative. And now we're getting into a discussion of the system dynamics methodology, which can get quite deep. I don't know if you have access to John Sterman's book. I would look there, or I would look on the creative learning site, right? And look at variables like, what's the phrase? Dimensionless multipliers and things of that sort. Someone asked how to identify variables in social community housing policy. I would deal with your stakeholders, the people who are involved in developing that policy, who are involved in building apartments or homes. The thing you'd like to look for, Sunil, is called the standard method. It's a short series of steps on how to go from zero to what Walt Disney calls hero in system dynamics modeling. It's by Jim Linus and Jim Hines. I can package that up for tomorrow. It's a free PDF. Okay, Hildy's got the soft variables. How Powersim can visualize simulation results. That's probably one of the most powerful tools that comes with Powersim Studio. Let's see if I can find my model here. Hold on, I'm going to try to open a much more sophisticated model so that you can see the interface. All right, let me go to home. Go turn it into print. So this is work for an existing client. Hopefully you see a sort of a colorful picture here, right? And I put hyperlinks on there. Let me go to this one. This is a map of oil, what's it showing right now? Oil wells in a physical location in my state that I live in. I'm going to go and pick a location. I did something wrong. I have to reset it. This might not work over the internet. Let me try it again. Yeah, it won't work right now. I'm not in the correct folder where all the data is. Oh, but I still could show you the interface. Why not?
We also, Len, we also have several questions in the chat. I haven't been
Okay.
closely monitoring them, but just want to make you aware of that.
The first resource to learn SD. Wow. All my experts out there, anybody have a suggestion?
Can I suggest the WPI course on the system?
The WPI course. Yeah. You can find, what is it, 80 courses at the Society website?
Yeah, I'm gonna put a link in the chat. There's our online course catalog. Some of them are free, some of them are paid. Some of them they have special discount for Society members. I'll put here in the chat the online course catalog and the System Dynamics Foundations course from WPI.
And Sorry points out that the SDS Summer School was a great start, and Len is organizing the summer school with Jake Jacobson and probably some others who are here on this. Len, do you remember the date? It's 2 weeks before next year's conference.
Yeah, I think it starts on the 5th or 6th of July.
Yep, and we'll be opening up registrations for that. They do fill up, particularly in the business, in the beginner courses. But I think it'll be late January, early February. We haven't yet settled on the registration start date for that. So
I see a question from Jing about financial analysis. Well, in those 200 or so functions built in, this is that same project that had the map. Let's see if I can do it. Here's a function called array net present value. So I'm bringing in a annual cost vector or an array and providing it a discount rate. And then I'm multiplying that rate times 1 year so I can get my units correct. So it's got a built-in NPV. Somewhere on this screen is the IRR calculation. I just don't see it right now. Can't remember where I put it. This is something in progress. Oh, it's over to the right. I see it now. Here's the IRR. Again, a built-in function that calculates for every project. I didn't go into arrays in this simple seminar, but you can array things. Like I had 4 sectors of a city and 5 different cities all running in the same model. As your arrays get bigger and bigger, you sometimes approach what an agent-based model could or couldn't do for you. Let's see, I'm scrolling through the chat. Yes, you can use graph functions. Thank Hilde. Are there examples of public health? Well, let's go take a look. Let me end the slideshow. Close some of these windows that are all over the place. Get my browser up. Go to Mind's Eye Computing. As long as the internet stays active, it'll take a little bit to get there. Okay, it's coming up. Go to resources at Mind's Eye Computing. There's about 100 models here for free and Zoom models. I'm going to John's textbook. And we have permission, obviously, from him to do all this. Now it's loading another piece of software. And there you have it. So every model that you see in green will run in Studio Express. Every model that's in red has more than 50 variables, so it will not run in Studio Express. And you're welcome to cruise through here and look. And if it's too busy for you, you can just minimize some of these branches and then make it bigger. What happens now is when you choose a model, let's see, what was it, a public health question? Housing policy. Oh yeah, there's a whole dissertation on that. Let's see, here's a market growth scenario. If I click this, it puts it in a little shopping cart for me. And then clicking on it, I can just save that file. I right click. So there are about 100 models here that will work in Express and demo version, and of course, the commercial versions. Likewise for, where is the zoo files, there are about 100 models there also that were converted from Vensim into Studio. Some of them we haven't even started to translate yet. Those are in yellow, but everything in green will run in Express. Everything in red requires a version of Studio greater than Express. Another nice resource is George Richardson's models. Another one, Jim Hines, is good stuff. I think you can download these as a whole packet. So someone asked earlier, are there places to learn system dynamics? Yes, there are many. Places to get good quality models, there are some. You fought your issue about monopsonies. We might take that offline. I'm going to send you my email address if I can find you in the participants list. There's so many, it's going to take a while to scroll through it. I've got you. And here's my okay. All right, let's go back to the chat. Any new questions? You can't, yeah, same person. You can test scenarios using graph functions, no problem. Someone asked about housing dynamics. I think the SD team, society team answered that. Definitely watch Martin Eskenazi's video if you can. I don't see, let's see, any more questions. Again, a reminder for those of you who are still there, you'll be getting all these materials. Oh, overview validating. Sure, Jay. Again, I'm going to send you to an article from, I believe, the 2009 or 2006 System Dynamics Conference. You'll find it on the Society website. The authors are Corbett, C-O-R-B-E-T, and Zagonel, Z-A-G-O-N-E-L. And they took at that time the 25 validating techniques for modeling with system dynamics. You can download that for free. Ecosystems assessment. That's a really good question. So the Powersim Studio website has a link to, I don't know, 60 or 70 ecological models. So models that are trying to model ponds and forests and all kinds of things like that. I might go there. I'm not familiar with innovative ecosystems assessment, but definitely poke around the System Dynamics Conference website prior to the year 2017. You'll find papers and models there that you can download. The other thing I would recommend is the System Dynamics bibliography. I don't have the SD site up, do I? That's terrible. I should have it. Get that up, show you where that is. That's also free, I believe, right? Rebecca, the bibliography?
Yes, the bibliography is free, and we have Raquel Buzagani working on it very much to try to make it a better resource for people. So I'll try to put a link in there. I'm not sure if we've got the searchable version in there yet or not. I think we do.
Here's the resources tab, and then I go down to bibliography.
Yeah,
you've got the legacy version. Okay.
I think we have the legacy version. I can't remember if we put. We have a work in progress fully searchable version that I think is in there. I
Yep.
have to look. I can't remember if we've opened it up for people to look at yet or not.
Yep.
Um,
Here are the links for the legacy version. That's the one I use. There's also a free software called Zotero. I'll spell that in the chat. You can get that for free. And then this version, let's see, which one is it? I think it's RIS zip that will import into Zotero. I never start a model without going to that bibliography.
Yep. I'm looking here. We did just recently update this page. So both the legacy version and the current version, which is the only one we're continuing to maintain, are available
Okay.
on there.
Okay. Let's see here. Looking for a question. Relationships for startups, governments. Oh yeah. Marcio, you're probably going to find something either in the bibliography or in the Sturman or System Zoo models. It won't be a complete model to meet all your needs, but you'll find something related to your topic. You can also search the bibliography with Zotero for keywords. Let's see if I can do this. We're almost out of time. I'm not the fastest guy in the world, but let's see if I can do it. I'm just going to open my Zotero, which will open immediately to the System Dynamics Society's bibliography. If it's still on my screen, you should see it coming up. Oh, there's only 15 items. Let me get the full. There's 12,542 items in the bibliography. Okay. All this stuff you see on the left are searches that I've done for students, clients, myself. Like here's one. Someone actually asked me to search on the word puberty. And I found one article. Racism, 2 articles. Healthcare, it's still loading. It's very slow. Let's see. Cancel.
If you search in our bibliography, I think you'll find a lot more on different topics like racism and
Right. This
Yeah.
one's geographic is the
Mhm.
key word. Supply and demand. I was doing a paper on that recently. I don't know why it's not letting me switch. But nevertheless, 12,000 items. Oh, I know why it wasn't. I'm writing a paper about supply and demand using system dynamics. 74 articles came up.
Mhm. Yep, if you search here on the word transportation, it's still, there are 225 that come up. If you just use the search on the right, you can fine tune it more
Oh,
in the
okay.
Airtable.
Oh, an Airtable. Okay.
Yeah, in Airtable, you can search titles and descriptions and they're tagged and things like that, or at least we're working on tags.
Oh, and the search now button here.
Yeah, on the upper right. Oh, yeah, if you, oh, there you are. So yeah, if you go there, that'll take you to the Airtable. And you'll
Okay.
see that we have the 12,426 records, which includes, I believe it includes the current conference and, the current proceedings, whereas the legacy version doesn't have some of the more recent ones. And you can
Okay.
search and filter and group and sort and all sorts of stuff in here. So you can just search on the upper right on transportation, you get like 225, and then you can filter, group, or sort on different fields.
Another plug we should make, Fernando and Rebecca, is to the special interest groups.
Mhm.
So there are many special interest groups. Maybe I can bring that up here.
Yeah, and I think there is a transportation SIG, isn't there?
Yeah, there is a transportation SIG. Where is it? Special interest groups right here. Here they're listed: asset, business, resilience, education, energy, et cetera,
Yeah.
and transportation.
Yep, and they're more than what's listed there. Those are just the ones for whom we have website pages.
Right.
So,
And then, of course, besides special interest groups, depending on what country you live in, there are chapters in different countries. And here's a list of them now. In fact, I think the Latin America chapter is holding a big conference next week, if I'm not mistaken.
that could be, it's hopefully on our event calendar.
Yeah, I owe them something. Oh, let's go to calendar. There's a South Africa competition going on.
So it's possible they are not on our,
I don't see them, no.
okay,
I
we'll
will-
reach out to
I'll
them,
send
make sure
Jorge
they get
a
on
me-
there. If you
Yeah.
are having an event in System Dynamics, we are trying to be inclusive and putting all System Dynamics and real systems thinking events on here as well.
Yep.
So feel free to
Esteban
reach out
answered.
to us.
Esteban, can you send a link in the chat for the Latin America for CLODs? Can you send us a link if you have it?
Okay. We have 1 minute left, Lon, I think.
Yeah, I think so. I want to say thanks to everybody for great questions, participation. Thanks to Powersim for financing this. Thanks to the Society for hosting it. Thanks to the University of New Mexico to get me an internet connection because I've been having trouble at home.
And I would like to say thank you, Len, to you and to the others that were here to provide support in the chat from Powersim, and definitely for the sponsorship to allow us to open it up to everyone. We have gotten feedback that people during these seminar series, we've gotten a lot of feedback that people want learning opportunities. And so Len and the previous session that we did with Nikki Zimmerman have helped us to respond to this. And we're looking forward to doing more of this. Please, Fernando is going to ask you to fill out a form, I think, to give some feedback. He definitely looks at this and we do react, and we're doing what we can to really improve learning opportunities here at the Society. So thank you for joining us, and thank you, Len and Powersim, for helping us to meet this need.
Thanks, everyone.
Thank you, Len.
I see Steinar at the bottom of the screen, of my screen. Oh, there's Hilda, the two folks from Powersim.
Mhm.
Hi, Eddie.
Hi, Lance from
How are you?
Jakarta. Yeah, fine.
Yeah. You're welcome.
Great. So anything you need to say, Fernando, to close out?
I was just going to ask people to respond to this survey. It's very short, less than 2 minutes. You give us your feedback and help us improve. That's all from me. And just if you don't remember, you can find a link to the System Dynamics Fundamentals course on our website in our online course catalog.
Okay, thanks everyone.
Thank you, everyone.
See you at the conference.
Thank you.